Welcome back to Infinite Limits. Today we're going to determine the limits from the left side and the right side, if they're infinite. And we're also going to find and sketch some vertical asymptotes of a function. All right. Sound pretty good? I think so. So let's get into this first. Infinite limits graphically. So first thing we're going to do is we're going to find the limit of f of x is equals 3 over x minus 2. And this here happens to be the graph. Notice there's an asymptote at 2. And there's a bunch of stuff going to infinity. So first thing it says here is the limit of 2 from the positive side. Now, positive side is over here. So as I approach 2 from the positive side, I'm going up, 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 up. Now, where is this graph going up towards? It goes up to infinity. So there, right there is a limit that equals infinity. As I approach 2 from the negative side, my graph is going to keep on going down. And if it goes down forever, it's going to negative infinity. Awesome. Now, what is the actual value at 2, the limit? These are not equal, and even if they were equal, they're unbounded, so the limit does not exist. Good job. All right. B. What is the limit as x approaches infinity? Now we're actually approaching infinity. So, on the x graph, the graph is going towards infinity. So it continues to go towards infinity forever. So if it's going towards infinity, where does this graph look like it's leveling off at? Okay, and there's a horizontal asymptote there. It's just not drawn. Where do you assume it is? Tell me the answer. Yell it out. It's at 0. It levels off at 0. What about the limit as you approach negative infinity? Going that way? That is also leveling out at 0. Now, because these both level at 0, is the limit at infinity 0? No. The limit of infinity is the same as the limit as x approaching positive infinity. It's like saying, what's the limit of 4 or what's the limit of positive 4? You can't really get the same. You're not approaching this from the same side because they're going opposite directions. So this answer is just 0 because these two are the same exact question. Ah, gotcha. All right. Infinite limits. Now, we're going to do this with a table at first, numerically. And then we're going to go up. So we did graphically. Now we'll do it tably. Tably? That'll work. All right. Now, we're going to find the limit at 2. If we type 2 in here, first thing you want to do is type 2 into your question. You get undefined as an answer. So, 3 over 2 minus 2. 2 minus 2 is 0. 3 divided by 0 is undefined. So we want to see if these guys are equal or they're unequal. Okay? So, let's just say they're unequal. Now, we don't know what they're going to be, but we'll assume. So, as you approach from the left, you get numbers that are, say, 100th, a 10th, and half less. All right? You could do the thousands, stuff like that. It doesn't matter. I take all these numbers, these three, and I plug them into this equation. 3 divided by open parentheses, 1.99 minus 2, close parentheses, negative 300. 3 divided by open parentheses, 1.9 minus 2, close parentheses, negative 30. 3 divided by open parentheses, 1.5 minus 2, close parentheses, negative 6. All right, did all the math for you. Type all these into the equation. If you do that, so this is approaching negative infinity. You got to jump a 5, jump a 10. If I pick a 999, it'd probably be negative 3,000. So it's getting closer and closer to negative infinity. Just like we did with the one-sided limits. Pick the limits from the right. As you approach 2 from the right, 1,000 or 100th, 10th, half. Right? You could always go 1,000th, 100th, 10th. I don't even know why I picked these numbers. You get 336, so you're going this way, so read it this way. 6 to 30 to 300, probably to 3,000. That's approaching positive infinity. These numbers, we were correct in our assumption that they're not going to be equal. So since they're not equal, the actual limit doesn't exist. But you have it from the left and the right. So left and right limits, one-sided limits, can be approaching negative and positive infinity, but your actual limit will be undefined. Non-existent. So what is the limit there? Negative infinity. So f of x approaches negative infinity without bound as x approaches 2 from the left. What was it when we approached from the positive side? Positive infinity. So the limit from the positive side is positive infinity. F of x approaches positive infinity without bound, all right, as x approaches 2 from the right. Got it? Easy, right? All right. I'm going to slow down a little bit. So what I want you guys to do is 2, 3, 4, 5. Say what the limits are. Your answer is going to be something. Right? As you approach C from the negative side, here's the negative side, you're approaching C, your graph is going down to negative infinity. As you approach C from the positive side, positive infinity. What's the actual limit as you approach C? Does not exist. C from the negative side, positive infinity. C from the positive side over here, negative infinity. What's your value at C? Does not exist. All right. C from the negative side, positive infinity. C from the positive side, positive infinity. So my limit is positive infinity, right? Nope, it's really DNA. Why is it DNA? Unbounded behavior. So you could say it has the tendency of positive infinity because they're both going up, but there really is no limit there. Just because the infinities can be at different levels, as we discussed earlier. Negative infinity from the positive side. Negative infinity, so the limit is negative. Nope, still DNA. Right? So anytime at least one of the pieces goes to positive or negative infinity, your actual limit can't exist. All right? But your one-sided limits still are valid. Got it? A little confusing? Hypotheticals. All right, number 6, determine the limits of each graph. So, number 6, what is the limit of 1 from the positive side? What do you think? Positive infinity. 1 from the negative side? Positive infinity. So the actual limit is DNA. Told you. Did you put positive infinity? Hope not. All right, number 7. Let me go here. Whoa! Almost fell off my chair. Bouncing around on stools here to help you guys out. All right, 1 from the positive side. Where's it going? Down to negative infinity. 1 from the negative side. Up to positive infinity. What's the actual limit? DNA. All right. All right, vertical asymptotes. Kind of touched on this last lesson. Hopefully you guys picked it up. If you didn't, now I'm going to hammer it home. You have a vertical asymptote if one of the 3 things happens. So, number 1, the limit of f of x as x approaches a, does that equal? Is negative infinity. You think it's negative infinity. It's not. It's still really DNA, but you say DNA. So you have a vertical asymptote here. If the limit is approaching positive infinity. One's going to negative, one's going to positive. You got a DNA. Now, I just told you you can't have a two-sided limit as negative infinity or positive infinity, right? But the limit, here you go. Now I'm going to blow your mind. The limit of f of x as x approaches a equals positive or negative infinity does not actually mean the limit exists. What? Right? All right. It tells you, and this took me like years to even comprehend because I hated it, but once you do it enough, you understand it. Well, you have to because it's fact. It tells you the limit fails to exist. So this actually says the limit doesn't exist by denoting the unbounded behavior as f of x approaches c. So we already know anytime you have unbounded behavior, the limit doesn't exist. So by this telling you the limit is negative infinity or positive infinity, all it does is it says both the things from the positive and negative side both go to infinity or both go to negative infinity. Although, because they both go there, your limit doesn't exist. So it's like a rule hidden in a rule. All right? Whole. Have to leave it. I can go on for like 20 minutes on why this is true. You'll get it eventually. Has a limit. So the left and right side limit of a whole are the same. The limit is the same from the left and the right hand side. There you go. Jump the gun there. And it's defined at f of x. Undefined. So at f of x, it's actually undefined, but the limit is the same from the left and the right. That means that if I reduce my problem, say my problem was 5x over x, and I took out the x's, made my answer 5, x equals 0 would be my whole. Even though I factored them out, meaning the limit is 5, because I factored out an x equals 0 on the bottom, where it's usually undefined, that's where my whole will be. Finding holes and asymptotes numerically. Let me go explain this to you one more time. now with pictures. See, pictures always help me more than words. Here's how to do. Step 1, factor and reduce. Go, factor and reduce, problem number 8. All right, x plus 4, x minus 2, and this is x minus 2, x plus 2. The x minus 2's factor out, leaving me with finding the holes. So my holes, notice right here, I'm going to factor out the x minus 2's. That's my hole. My hole is the reduced part. So x minus 2, the part I factored out from the numerator and denominator equals 0. That means I have a hole at x equals 2. Does that make sense? That's what I was trying to explain to you, but I think with the picture. So because I factored this out, yes, I can still find the limit now with it, but I know there's a hole there. Part 3, find the asymptotes. Do you know what the asymptotes are? Not the reduced part. That's you set the denominator equal to 0. So whatever is left here, when that equals 0, my answer is undefined. That's going to be my asymptote. So after I factor this out, I'm left with this. I set my denominator equals to 0. X equals negative 2 is my asymptote. Look over here. Negative 2 is an asymptote. At 2, I have a hole. See that? All right. 4, find the limit at the asymptote. So I can see if they're positive or negative. The way you do this is you make some tables. You approach from the left and the right-hand side. So the limit of negative 2 as x is approaching negative 2 from the negative side, the left-hand side. So negative 2 is here. You're going to subtract the 10th, maybe subtract the half. You can also do 110th. Take these two numbers, plug them into, you can plug them right into that equation right there. You get negative 19 and you get negative 3. You can see these are jumping up towards negative infinity. This answer is going to be negative infinity or positive infinity. So just look to see if the numbers are decreasing or increasing. So as I approach negative 2 from the positive side, my negative 2 is over here. So I'm going to add a 10th and add a half. So that's negative 1.9, negative 1.5. Take these two numbers, plug them into that equation. You get 5 and 21. As I'm getting towards here, the number is going up, so it has to go up to positive 50. And you can pick any two numbers that are bigger than this. It doesn't matter what two numbers you knew, because as soon as you plug them into the equation, you just see how they're moving. Right? Same thing here. I have to pick two numbers though. You know, pick the same thing. Alright, so for problem number 2 now, find the vertical asymptotes of the function. Go. Alright. When the answer is undefined, you have a vertical asymptote. So that's when the numerator equals whatever and the denominator equals 0. So when 2 times x plus 1 equals 0, divide both sides by 2. Subtract 1 from both sides. So when x is negative 1, that's where my vertical asymptote is. Guess what? Plug this in the Desmos, check your answer. Boom! That's what the graph actually looks like. I was right. Where is the asymptote here? Where the denominator equals 0. Add 1 to both sides. What number squared equals 1? Not just 1, positive or negative 1. That's where my two asymptotes are. Guess what? Plug this guy into Desmos. Boom! Graph looks like that. We're right. Cotangent. Now cotangent is cosine over sine, right? Cotangent is undefined when what equals 0? When sine equals 0. Now when does sine equal 0? At 0, at pi, at 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, at n pi. N is any integer. Oh, there you go. Boop, 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 boop. You can also go negatives. And that's actually what cotangent looks like. It looks like an upside down tangent. Good? Why did I throw a little trick in there? Alright, so 9 and 10. I want you guys to follow these 4 steps. I want you could look at the graphs just to help you out, to make sure you're correct. Alright? But I want you to solve this without the graphs. The graphs are here with the answers on them, just so you can check your answers. factor, reduce, find the holes, find the asymptotes, find the limits at the asymptotes. Go. Got it? Let's go. Factor and reduce. I could take a x at the top, x at the bottom. All right. What cancels out? The x's. So what is my hole at? X equals 0 is the hole. Here's my graph. X equals 0 is my hole. What is the y value of the 0? We'll just plug 0 in here. 0 minus 2 over 0 minus 1. Negative 2 divided by negative 1 is 2. 0, 2. There's my hole. Easy. 2, find the asymptotes. Set the denominator equal to 0. Add 1 to both sides. X equals 1. X equals 1. Asymptote. Alright? We're not doing, we're just doing vertical. If I want to find horizontal, I could type infinity and negative infinity in here. And then you can use, do we know how to do that yet? Oh yeah. And then you can just use the L'Hopital's rule. Right? Yeah. Alright. Answer would be 1. Huh. Alright. Anyway, let's find the limit as 1 approaches from the negative. Some numbers, 1's here. Numbers a little bit less than 1. Plug them in there. What does this graph look like it's going towards? Positive infinity. Guess what? Positive infinity. 1 from the negative side goes in there. A little bit higher. 1 from the positive side, sorry. Plug these two numbers into here. Negative 1, negative 9, negative 1, negative 9, negative 10. Easy? Hopefully. All right, number 10. Factor. What's that? X plus 1, x plus 2, minus 9 and plus 2. Yep. Plus 2's cancel out. Find your hole. X plus 2. Subtract 2 from both sides. X equals negative 2. If I type negative 2 in here, negative 2 plus 1 is negative 1 over negative 11, which is 1 over 11. 2 and about 1 over 11. Negative 2, 1 over 11. There you go. X minus 9 set equal to 0. Add 9. Guess what? Asymptote at 9. The limit, as x approaches 9 from the negative side. 9 goes here. You get two numbers leading up to 9. You take these two numbers, you plug them into that equation right there. You get negative 19, negative 99. Your graph is obviously going down to negative infinity. You're doing pretty good. 9 from the positive, so 9 goes here. Two numbers leading up to 9. Take these two numbers, plug them into that equation. I got 21 and 101. Positive infinity. There you go. Look at that. You guys can almost make these graphs. Doesn't it look awesome? Happy yet? Alright. Problem 11. Oh no. Now we're going to get into end limit behavior. Now this is stuff I kind of just made up to help you guys out. Alright. The way end limit behavior works, all these levels I just kind of put together. The higher the level, the more difficult it gets. Level 1 is like the most basic. So what it says is the limit of k as x approaches infinity. So the limit of k is just a constant, the number. So for instance, the limit of 4. Okay, what's the limit of 4 as you're going towards negative infinity? So what's the limit of any line going across as you approach negative infinity? It would just be that number, k. What's the limit of k as you approach positive infinity? It would just be k. So what's the limit of 4 as you approach negative infinity? 4. What's the limit of 4 as you approach positive infinity? 4. So the limit of any number, as we said before, no matter what you approach is just that number. It's the same concept. Now we're just dealing with infinity and negative infinity. What's the limit of x as x approaches infinity? Now x is just your identity graph. So you just type in negative infinity for x. So what do you think your answer is? Negative infinity. What's the limit of x as x approaches positive infinity? Positive infinity. That's it. That's pretty easy, isn't it? All right, next one. 1 over x. That's this weird looking graph. 1 divided by negative infinity is 1 divided by the biggest number imaginable. Does it look like I'm leveling off at? 0. 1 divided by positive infinity. We're going to be using this later on. What's 1 divided by, type in your calculator, 1 divided by, type in a whole bunch of 9s. What do you think the answer is? 0. It's pretty much a horizontal asymptote at 0. So 1 divided by a positive or negative infinity is always going to be 0. And that's going to be very important in about 5 minutes. Got it? Can you remember 5 minutes from now? I'm going to refer to this. All right, let's go. Level 1 basics. The limit of 4x as x approaches negative infinity. What do you think it is? Well, let's look. The rule, limit of kf of x is k times the limit of f of x plus or minus infinity. Huh? Here comes some concepts. So 4 times the limit of x as x approaches negative infinity. What's the limit of x as x approaches negative infinity? You plug in the negative infinity. Now, get this once and it will be good forever. What do you think 4 times negative infinity is? Ready? Yell out your answer. Negative infinity. Any number times positive infinity, as long as that number is positive infinity. Any positive number times negative infinity is negative infinity. The only thing that changes the number, is the sign in front could change it from positive to negative. Go do these 3. These use your basic rules. Go. Number 12. Negative 3 times negative infinity. Well, negative times the negative is a positive. Wait a second. Not negative. It's negative, and negative is a positive infinity, which is your answer. Okay? Got it? You always have to deal with the signs. What is the limit of a constant as x approaches positive infinity? It doesn't matter. Limit is negative 7. Even if this was a negative infinity, it would still be negative 7. The limit of 8 divided by negative infinity. Well, 8 times 1 over infinity. What's 1 over negative infinity? 0, as we said before. Any number times 0 is 0. Got it? Awesome. Ready to take it up a level? Yeah. Boom! Level 2. That's a quick level up, right? Alright. Limit of infinity to a power equals infinity. Positive infinity to any positive power is infinity. N has to be 1, 2, 3, 4, 5. Right? Limit. Because infinity to the 0 power is 1. Infinity to a negative power is that number over infinity, which becomes 0. Alright. Negative infinity. Any power is negative infinity or positive infinity. Why would I say or? Anyone? Good. Because negative infinity to a what? Odd power, 1, 3, 5, 7, 9, blah, 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 is negative infinity. Negative infinity to a even power, 2, 4, 6, 8, 10, blah, 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 is always going to be positive infinity. Because a negative times a negative is a positive. All right, 15 through 17, go. 15. 6 times infinity squared. Well, infinity squared is infinity. 6 times infinity is infinity. This becomes easy. Actually, I like these. Negative 4 times infinity to the 4th. Infinity to the 4th is infinity. A negative number times a positive infinity is a negative infinity. The 4 means nothing. All we care about is the sign. Negative 5 times negative infinity to the 5th power. A negative number to 5 powers is still negative. Negative 5 times negative infinity. Negative times a negative is a positive infinity. Having fun yet? Awesome. All right, do now. Day must have ended, day must be beginning. All right, so negative infinity to the 8th power. Negative to an even power is a positive infinity. Negative times a positive is a negative infinity. All right? Infinity to the 22nd power. Still infinity. 13 times infinity. Still infinity. Negative infinity, so you pull out the 17 over 2, which is a positive number. Negative infinity to the 5th power. Negative 5 times is still negative. Any number times negative infinity, positive and a negative is a negative. Finally, D is negative infinity. Nope. It's constant. There's nowhere to plug this into. There's no x's to plug this into, so you just leave it as -3. Right? Kind of liking that one, right? Alright, end behavior matches the... Oh, we're about halfway through. That's good. End behavior matches the end behavior of the highest degree term. This is L'Hopital's rule. So n right here is the largest exponent. The largest exponent is the highest degree term. So these c's are just constants, and then x's to all these powers, you go in ascending order. Whatever the highest one is, that's the constant you attach. So, very simple concept here. Which one of these terms is the highest? 8, 6, 5, 2, or nothing? 8, right? So all you do is you take this and you just get rid of everything else. So 6x to the 8th is the highest term. So that means that I don't care about you. I don't care about you. Definitely don't care about you or you either. You're all useless because this infinity is bigger than these ones, so it kind of like gobbles it up like a black hole. All right, so right there. We're just going to take whatever this limit is to this, and all these things are negated. They don't matter. So 6 infinity to the 8th power, negative. Negative infinity to the 8th power is positive infinity. Positive times a positive is positive infinity. See? That's it. L'Hopital. 1920, go on your own. You did. Awesome. What'd you pick? I picked 5x to the 5th, and if you didn't, you were wrong. Those guys, bye-bye. Limit. X approaches negative infinity, 5x to the 5th. Negative infinity to the 5th power is still negative infinity. Times 5 is still negative infinity. Right? 4. Negative 8 times infinity. Negative and a positive is a negative infinity. All right? Yes, it is that easy. You ready? Now, 21 is easy. 22 and 23 is still technically polynomials. May give you a little trouble, but really shouldn't. 7 is bigger than 5, but this is a positive number. Positive numbers are always bigger than negative numbers. So 5 times negative infinity to the 5th power. 5 times negative infinity is negative infinity. This one, 7x to the 8th is good. You also need to keep the denominator though too. You can't just get rid of it. So this is technically 7x to the 8th divided by negative 3. So 7 over negative 3 times negative infinity to the 8th power. That becomes a positive infinity. Now, another way to do this is you can divide all 3 of these by 5, and you just keep this one because that's the 8th power. All right, that's where I got the 7 over negative 3 from. You don't have to do this. You can jump right to here, but this helps some people out. Negative infinity to the 8th is a positive infinity. Negative times a positive. Answer is negative infinity. Got it? No! Why not 10? 10, 9. Whoa, there's someone snuck a negative 12 in there. You also have to keep the sign that goes with it. And that's over 5,781. Negative 15 over this. It doesn't matter. It's a negative number. Positive number to the 12th power is positive. Negative this times positive that is negative 15. Right? That's polynomials. 3 levels good? Guess what comes after 3? 4. Level 4, now we're going rationals. The limit of rational functions as x approaches positive or negative infinity. Now there's one simple rule, and that simple rule is take the highest degree numerator, take the highest degree denominator, then reduce and solve. Oh, this is the L'Hopital rule as well. I don't think the other one was. I think you need a fraction for that. So what's the highest degree numerator? 3x to the 5th. Highest degree denominator? 6x to the 3rd. Now the reason the other ones were just polynomials, not rational, is because you could divide each number by that because there was only one number on the bottom. You didn't have to choose between the two. So you got 3x to the 5th over 6x to the 3rd. These don't matter. Now you're going to do is reduce. 3 divided by 6 reduces to 1/2. X to the 5th over x to the 3rd. If I take 3 x's out of here, I'm left with just the number 1. 5 minus 3, I'm left with x squared on top. All right? So I get 1/2 x squared, or just x squared over 2. Plug my negative infinity into the x squared. Negative infinity squared is positive infinity divided by 2 is still positive infinity. Positive infinity divided by 1 billion is still positive infinity. Numerator, denominator. What does that reduce to? 3 over 6 is 1/2, and the x's cancel out. What's the limit as x approaches negative infinity of 1/2? It's a constant. Answer is just 1/2. Right? 25 is 26. Go. Pause. Unpause. Ready to go? Here we go. 7x, 13x. Cancel the x's out. It's a constant. Limit of a constant is just what that constant is. Right? 26, not that easy. Do this one quiet. 4x squared, 2x cubed. 4 divided by 2 is a 2. Now, take out the whole x squared. Take out 3 here. You're left with an x on bottom. So you're left with 2 over x. Okay? Now, when I put infinity on the bottom, 2 divided by infinity, any number divided by infinity or negative infinity, any number divided by positive or negative infinity is 0. There you go. All right. 4 more. Go. 1, 2, 3, 4. All right. 27. Highest. 3x over 2x. Take those x's out. 3/2. Constant is 3/2. Are these great? Don't get too complacent. I threw some tricks in here. All right. Right here. 5x squared, negative 2x squared. Not here, though. 5x squared cancels out. X squared left with 5 over negative 2, which is negative 5/2. Didn't think that was a trick, did you? About 29. I get some people sometimes. 3 and x. Answer's not 3/4. 3 divided by x, 3 divided by negative infinity, 3 divided by positive or negative infinity, same answer, and that answer is 0. That one get you? No? Okay. 5x to the third, 12x to the fourth. Cancel out the x third, leaving with 1x on bottom. 5 over 12x. 5 over 12 times infinity. 5 divided by infinity, which is 0. I didn't throw the tricky ones in yet. They're just making sure you stay on your feet. Now we come with some tricky ones. All right. Negative 5x to the sixth. 2x to the fourth. Take an x to the fourth, leaving with negative 5x squared on top. Over 2. Negative 5/2 times negative infinity squared. Negative infinity squared is infinity. Negative 5/2 times infinity is negative infinity. Still good? Pretty impressive. 13, 18. The x to the 8's cancel out. That's your answer, 13 over 18. How we doing? Yeah? Uh-oh. If you said 7x squared was your highest degree term on top, you are 100% wrong. Here's where trickiness comes in. What do I have to do here? Distribute. 7 times x squared minus times negative 5x, negative 35x cubed. 7x squared times 13, 91x squared. I have to expand this. I don't distribute the x in first. 2x minus 6 times 2x minus 6. 4x squared minus 24x plus 36. I have to take this x now, and I have to distribute it into that. 4x to the third, negative 24x squared plus 36. After I did all that work, now, highest degree term on top, highest degree term on bottom. So you have to expand before you take your terms. Negative 35, x to the third cancels out, over 4. Negative 35 over 4 is your answer. If you got that, awesome job. If you didn't get that, you'll get the next one. All right? We'll go back to tough problems like that in a little bit. Now let's go to level 5. Radicals. What do you think the limit of radical x as x approaches infinity is? Infinity. Square root of infinity is infinity. What do you think the square root of negative infinity is? The limit of that is, doesn't exist because the answer is undefined. So negative number is undefined, so the limit actually is a DNA. Got it? Limits for radicals as x approaches positive, negative, infinity. Pick the highest degree term still. 3x cubed. Square root of 3x cubed. Now we're going to plug this infinity in here. 3. What's infinity to the third power? Infinity. What's 3 times infinity? Infinity. What's the square root of infinity? Infinity. Alright? That's not too tricky. Once we start messing with the symbols, that's not tricky. Alright? 4. Infinity to the third is our highest degree term. Infinity to the third is infinity. 4 times infinity is infinity. Square root of infinity is infinity. Alright? The only time you have to be careful is when you're dealing with negative signs. Now this is a cubed root. That means the sign could be negative or positive inside. So we're going to take the highest degree term from the left, highest degree term from the right, cancel out the rest. Oh, how can I reduce this? I can take x's out here. So this is the limit of negative, x approaches negative infinity of the cubed root of 5 over 7. Guess what? There's no x's here, so our answer is the cubed root of 5 over 7. Which, if I typed in the calculator, I have no clue what number that is. I didn't put it either, so I guess I don't care what number it is. It's a number less than 1. And that'd be higher than 0. Alright. Ready for the next problem? I want you to do 37, 38, 39, and 40. Just make sure. Alright. Sorry, just making sure my camera's not dead yet. Alright. 37. Highest degree term on top is x squared. Highest degree term on bottom is 3x. So now we're kind of mixing up a radical and a rational. A rational. Rationatical? No? No good. Alright, so square root of x squared. The square root of x squared. X. Alright, so x over 3x. What cancels out here? The x's. Your answer is actually limit of x approaches infinity is 1/3. Look at that. Got you there, right? If you plugged in infinity too fast here, you would have just got infinity over 3 times infinity, which you couldn't do anyway, so you shouldn't. So you always have to reduce the x out to get either top or bottom before you do it. Right? You can't just start plugging infinities over there. 2x squared, 7x. Now, what is radical 2x squared? You could separate it. It's 1.41x, or square root 2 times x. Right? Because I take the square root of each one of these. Square root of 2 times x. This is an x all by itself, see? There's no radical above it. X's cancel out. Your answer is radical 2 over x. Alrighty? Oh, we got you over there. Got you over there. Negative 5x squared over 8x. Cancel out the x squareds. The cubed root of negative 5 over 8. Can you have a negative under a radical? You can if it's a cubed. That's your answer. If you want, you can actually pull the negative out front. Just make it negative cubed root of 5 over 8. That probably looks a little bit nicer than that, but it doesn't matter. All equals the same thing. That's the wonderful thing about math. All right, let me back out and back in. Right there, negative 3x to the 4th. Negative 9x to the 7th. Ooh, this is going to be a weird one. All right, so negative 3x to the 4th over radical negative 9x to the 7th. Now, this is probably the most complicated one, so you really got to pay attention if you've just been like kind of dozing off here. So when I take the radical of here, you would say, oh, radical of negative 9 has to be undefined, right? But technically, you're doing negative 9 times negative infinity to the 7th power. So how many negatives is that? 1 plus 7 is 8 negatives, which is going to make this answer on bottom eventually, what? Positive. Okay? So if I'm just dealing with these infinities, negative infinity to the 4th is positive times a negative, so I'll have a negative times a positive, which is a negative number, over the radical, right, of a positive. So my answer should be negative. That makes sense? Because I have 8 negatives on bottom when I really just solve it out before reducing anything, my answer is going to be positive. Now, negative 3 x to the 4th over 3 times x to the 3.5. Why is this 3.5? 7 divided by 2 is 3.5. Or you could say 7/2. 4 minus 3.5 is negative x to the 0.5. The 3's cancel out, leaving me with 1 negative. Now this is negative x to the 0.5. You know what that is? X to the 1/2, or just a square root of x. So it's negative square root x as x approaches infinity. Now the reason I'm using infinity here, not negative infinity, is because, as I said before, we know the answer is not going to be undefined. So negative radical infinity, so follow me, is negative infinity. If you don't believe me, guess what you could do? You can go on Desmos, plug that nice equation in here, and actually let's see what it looks like. Alright, 41. Rarely do you get things where you have to go that crazy. Take the top, take the bottom, 5x squared, square root of 25 is 5, square root of x to the 4th is 6 squared, over, oh, that should say negative 9x. I don't know why it says 3. It doesn't matter anyway, to the number. So it's 5 over negative 9, 5x, 5 times negative infinity over negative 9, like I said, I should say 9, is negative infinity. Alright? Gotta fix 41. That's in my brain for 5 minutes from now. This one, negative x on top, negative 6x squared on bottom. Now, this one, however, watch what happens. Negative 6x squared on bottom, right? No matter what I plug in for this x squared, the bottom's always going to be negative. So when I square a negative number, it becomes negative 6 times positive infinity. I end up with radical positive infinity. What happens when I get radical positive infinity? Undefined. So no matter what I do on the bottom, my answer is always going to be undefined. Therefore, the limit doesn't exist. All right? 43, 44. Almost done. I didn't realize this lesson was so long. 8x to the 6th, 27x to the 6th. When you cube them, that means you're dividing each of these numbers by 3, or you can just cancel them right out here. The cubed root of 8. What times what is 8? 2. What's the cubed root of 27? What times what is 37? 27. 3. So your answer is the cubed root of 8 over 27, which is 2/3. That came out pretty nicely, didn't it? This one right here. X is approaching negative infinity. So, negative infinity to the 9th power. Negative infinity to the 9th is a negative times a negative infinity, which is the square root of positive infinity, which is positive infinity. It actually gave us an answer. All right, ready to do the fun problem? Go. You have to, and we skipped this one in class because it was long and tedious, but what you have to do here is you're going to have to expand, expand, expand. First expansion. Alright, got the first expansion. You square that. This is 5x squared minus 8 times 5x squared minus 8. Alright. 25x to the 4th minus 80x squared plus 64. Alright. Now we're going to expand this guy. Now that means you're going to do 3x minus 4 times 3x minus 4. When you square that, you get 9x squared minus 72x plus 16. Then you have to multiply it by 3x minus 4 again. Distribute that in. 1, 2, 3. 1, 2, 3. And it ends up being 27x cubed minus 252x squared plus 336x minus 64. This is also, if this is A and this is B, A cubed minus, what is this? A squared B plus B squared A minus B cubed. See if you remember that equation. Distribute the 3 into that. 15x cubed minus 45x. Alright, so this is just going to be 3 times this stuff times that stuff. Alright, now you have to distribute the 3 in to all those. When you do that, you get 75x cubed minus 240x to the fourth plus 192. And then you're going to have to distribute the 15 to all these, distribute the 45 to all these. Now, let me tell you something. That gives you this big number. Do you have to do all this? And it gives you this. No, you don't have to, because all we care about is the highest degree term and the highest degree term. And then what we actually do here is we cancel out the x to the 6's. We take a 5 out. No, we take a 15 out. 5 over 27. If you get to, say, this point, 5 squared is 25x to the fourth. That's the one we really care about here. This times this is 75x to the sixth. Here, all we really care about is this to the third power, which is 27x to the third, because that's the highest degree term. And then all we really care about is this times this, because that gives us x to the sixth. That gives us the highest degree term. So if you do something like that, you can shorten this up. If you want to expand it all, you can as well. All right? No, you're not going to get anything this difficult, but it's just to show you how expanding all this stuff, just all this work, leads to such a simple answer. Got it? All right. What we're going to do now is we're just going to finish with some graphing. What have we got? 4, 5, 6, 3 simple problems, just to reiterate what we did in the beginning. So first one. The limit of f of x as x approaches negative 4 from the negative side. Here's negative 4. From the negative side is right there. Your answer is 6. Limit as you're approaching negative 4 from the positive side. Answer is 4. What's the actual limit here? These are not continuous, so the limit does not exist. What is the limit of 2 from the negative side? Now here's 2. As I approach it from the negative side, my answer is 2. Even though there's no actual closed circle there, a line is just an infinite number of closed circles, which I said earlier. The limit of 2 from the positive side is still 2. So what is my actual limit here? Unbroken graph. Limits are the same from both sides, so my limit is indeed 2. Here's your infinite limit. The limit as x approaches infinity, negative infinity. So as it's going towards negative infinity, what's this graph doing? It's going down to negative infinity. The limit as the graph approaches positive infinity. As you can see here, the graph is going to continue to go up, and my answer is going to be positive infinity. Got it? Awesome. F of negative 4. All right, so what is the actual value at negative 4? The value would be 6. F of 2. What's my actual value at 2? 2. F of 0. What's my actual value at 0? The answer is 0. All right. We all good? Perfect. 47. The limit of f of x is negative 2. Negative 2. As you approach negative 2 from the negative, what's our graph doing? It's going down, and it's going down to what? Negative infinity. As you approach negative 2 from the positive, it's going down, and it's going down to negative infinity. Therefore, my graph is what? DNE. Yes, unbounded behavior, DNE. What's my actual value at negative 2? Well, here we go. At negative 2, my actual value is negative 2. All right. The limit of f of x as x approaches 0 from the positive side. 5. 0 from the negative side. 0. What is my actual limit here? These are not touching, so the limit does not exist. What is f of 0? Open circle, up, closed circle right there. The closed circle is at 5. As I approach 0 from the positive, as I approach positive infinity is this way. My graph is going up, and it's going up to positive infinity. As I approach negative infinity, what's my graph doing? It's going up as well. So it's going up to positive infinity. Remember, up is positive infinity, down is negative infinity. All right? Last problem of the day. Now, the limit of f of x is negative 2 from the negative side. Negative 2 from the negative side, what's my graph doing? It's going down to negative infinity. Negative 2 from the positive side, it's going up to positive infinity. The limit of negative 2, unbounded behavior, limit doesn't exist. What is my actual value at negative 2? Asymptote, Value is undefined. What is my actual, okay, what do we got here? F of 4 from the positive. So we're approaching 4, and we're doing it from the positive side. So that guy is going up, or gal is going up, and to infinity. 4 from the negative side going up, and where are you going up to? Going up to infinity, opposite positive infinity. What is the actual value here? It's not infinity. As you can see, they're not totally going up at the same time. It does not exist because of the unbounded behavior. What is the actual value at 4? Oh, look it. I got a closed circle here. Value is 2. As I approach infinity, what's this graph going towards? It's leveling out, and it's leveling out right here at 0. What about as I approach negative infinity? It's also leveling out, and it's also leveling out at 0. So there's a horizontal asymptote here at 0. See that? See all these things we just found out? Guess what? Now you're experts. Hopefully, you're an expert at limits now. Before you weren't, but now you are. All thanks to me, right? All right, so today you learned how to determine limits from the left and the right, determine what to do when your graph is going towards infinity, when your graph's going to negative infinity. Do that graphically and analytically. Okay, you learned a whole bunch of rules. And if you need any extra questions, any practice questions, have any questions, come see me, and I'm going to help you. All right, so until the review is going to be on 2.4 and 2.5. We'll review, we'll test it, and then we'll go right into derivatives. So, to the next lesson, have a good day.